In this video, we're going to look at comparison processes. The corresponding reading this week will focus on Hasso's theory of justice, which is a specific type of comparison process theory. But in this video, I want to look at the broader theory of comparison. This theory explains how people understand rewards or punishments which they experience. How do you decide what is fair and what is not fair? And how do you react when you encounter unfairness? This equation, which summarizes comparison theory, gives us answers to those questions. In my experience, sometimes students in sociology, especially undergraduates, have a strong negative reaction to mathematics. But I really think that reaction is more of a self-handicap than anything else. If you think of yourself as not a math person, then you're going to be turned off by the more quantitative side of social psychology. And if you maintain this mindset, you're going to end up missing a lot of really interesting ideas. I'm not going to ask you to do any math for this course, but I do want you to be open to what you can learn by playing around with the ideas that are expressed in formulas like this. The equation is your friend. It's going to help you understand important social processes. And after all, that's what this course is all about. To explain how this equation can help us understand fairness, let's look at each of the terms in detail. Z represents the comparison evaluation. Z predicts both whether or not a person thinks a situation is fair, and if they think it's unfair, how unfair they think the situation is. Both A and C represent the thing being compared. For simplicity's sake, I'm going to call anything that gets compared a social object. Social objects can be tangible, like income or the amount of property you own, but they can also be intangible, things like how attractive you are or how much self-esteem you have. Social objects can also be a good, which is something that people want. People want more money and more property. They want to have more self-esteem. They want to be more attractive. But it can also be a bad, things that people don't want. For example, we can think about comparing salaries. A salary is good. People want to get paid. Punishment for a crime, on the other hand, is bad. People do not want to be sent to jail. No matter what is being compared, in this equation, A represents the person's actual holding. How much of the resource they actually have. For salary, we could measure a person's actual holding by looking at their annual income. For prison sentences, we could look at the number of years someone has been sentenced to serve in a prison. C represents the comparison holding. C is the amount that A is being compared to. So this theory is ultimately modeling a comparison between the actual holding and the comparison holding. The comparison holding is the reward or punishment that a person expects in a given situation. Comparison holdings are the social part of this social psychology theory. The theory assumes that for any social object a person makes a comparison on, they're going to compare their actual holding with a comparison holding of some specific group. In other words, people do not necessarily compare their actual holdings with the holdings of everyone in the world. Instead, they draw a comparison between themselves and a specific social group that's relevant. For example, for salary comparisons, you wouldn't compare the salary that you earn to the salary of everyone else in the world. Instead, you're much more likely to compare the salary that you earn to the salary of other people doing work that's very similar to the work that you do. The theory doesn't give us details on how to figure out what group is selected by the individual. That problem is left mostly as an empirical question that a researcher would need to address before they can apply the formula. In this week's reading, Hasso deals with this problem as it relates to grades. She points out that high school and middle school girls are probably much more heavily influenced by the grades of other girls in their class as opposed to boys in their class. She thinks that girls are more likely to compare their grades to other girls. And she has to develop a way of accounting for that difference in her analysis. As you'll see when you read her work, there's a lot of math involved. But again, you don't need to understand the math perfectly. I just want you to know that when we think about how people compare themselves to others, we have to take into consideration their membership in different social groups. We have to think about how their positions in different social structures influence who they think is a relevant group. However, once you've identified the group that an individual is comparing themselves to, you can predict how they think about the distribution of some social object. Let's look again at the comparison formula. Notice that the actual holding is being divided by the comparison holding. This gives us a ratio of actual to comparison holdings. Using salary as an example, let's assume someone is making $100,000 a year. In that case, A would be $100,000. Let's say that the comparison group is a worker's peers in a specific corporation. C will be equal to the average salary of that peer group, which in this case is $150,000. So we get a ratio of actual to comparison holdings, which in this case is 2 to 3, or about 0.67. To figure out how fair the employee will think that this is, what we do is take the natural log of that ratio, which in this case is about negative 0.41, and we multiply it by the term theta. In a second, I'm going to explain why we use the natural log here, but first I want to explain theta. In the equation, the Greek letter theta represents a constant that models two important things. It represents an individual's sensitivity to unfairness, and it represents an individual's understanding of the social object in question as good or bad. When theta is negative, it means that the individual understands the social object as bad. For example, if prison sentences were being compared, then theta would be a negative for most people. That's because most people don't want to go to prison. In this case, salaries are being compared, so theta is positive. That's because salary is understood as a good. People want money. The absolute value of theta models how sensitive someone is to unfairness. This value is larger for people who are more sensitive to unfairness. The larger the absolute value of theta gets, the larger the impact of an unequal ratio of A to C will be. To put that in practical terms, some people are very sensitive to minor injustices. It doesn't take much for them to complain. On the other hand, there are people who are much less sensitive and will tolerate seemingly large injustices. The absolute value of theta models this psychological phenomena. If you have data that includes people expressing ideas about fairness or unfairness, then you can actually estimate this value for a population. In other words, we can look and see for a given group of people how sensitive they are to unfairness on average. There are also theoretical ways of measuring theta, but we're not going to go that in depth. Okay, so why do we take the natural log of the ratio of A to C? Well, this actually does two important things. First, it transforms the sign of the ratio in a conceptually appropriate way. The natural log of values greater than 1 are going to be positive, and the natural log of 1 is 0. Finally, the natural log of values less than 1 are negative. This property of logs is useful for modeling comparisons. Recall in our example, we divided 100,000 by 150,000, which gave us a value of about 0.6. Well, if we take the natural log of that value, we get negative 0.41. Notice that our term is now being expressed as a negative. That should make sense to you because in this situation, someone is comparing what they make to the average of their peers, and they find out that they make less than the average. So if a person were making less than average, we might expect them to evaluate that as bad. If the person were making the average amount, then the comparison would wind up as 0. And if they were making more than average, then the comparison would end up being positive. The second important thing that the natural log gives us is a way to model the psychological sensitivity to loss. It is a psychological fact that people are more sensitive to loss than they are to gain, and this fact matters when it comes to comparisons. It's clearly unfair for someone to make $20,000 a year when their peers are making $150,000 a year. But it's also unfair for someone to make $200,000 a year when their peers are only earning $150,000. In reality, people are going to be way more sensitive to making less than what is fair than they are to making more than what is fair. To illustrate this, I have graphed our salary example. In this graph, the y-axis represents Z, the comparison evaluation, and the x-axis represents different actual holdings that a person could earn. The higher the absolute value of Z, the more unfair the observer thinks the situation is. In this example, the comparison holding, C, is equal to $100,000. Notice how for an actual holding of $100,000, the value of Z is 0. This represents a comparison of perfect fairness. When A equals C, Z will always equal 0. Positive values of Z represent unfairness that favors the person making the comparison, and negative values of Z represent unfairness that disadvantages the person making the comparison. Look at what happens when we model a situation where someone's salary is $180,000 a year, but they're comparing their salary to $100,000 a year. We have an absolute value of Z that is greater than 0. It's positive, but it's not that high above 0. In this case, Z is equal to about 0.12. $180,000 is $80,000 more than the comparison holding. But what would happen if we modeled a situation where someone was making $80,000 less than the comparison holding? It's the same absolute difference, but now it goes against the recipient instead of favoring them. In this case, Z is negative. But look at the absolute value. It's much greater, more than twice as large as before. This is because we care more about negative unfairness than positive unfairness. And this model captures that psychological process. You can see this across the entire graph. Once the comparisons drop below perfect fairness, the rate of change increases. People get more sensitive to the unfair situation. And that's how the equation works. It's a very simple model, but it can be used to describe pretty much any comparison process. There are special cases that require an extra step or two. For example, you can model ordinal holdings, so stuff like beauty or how long you have to wait in a line. But to do that, you need to express A or C as a position in a rank order. But even with that relatively simple change, this is still quite a versatile theory. We make a lot of comparisons in our social life, and now you have a way to predict how people are going to evaluate them. You can apply this theory to lots of different situations. In your readings, Hasso uses the theory of justice to explain how middle and high school kids are thinking about their grades. But you can use this idea to explain a great many things, from small or trivial things like how patient someone will be when they're waiting in line, to very large and socially important things, like how dissatisfied a community is going to be when they're interacting with the justice system. Okay, that's all for now. I'll see you in the next video.